or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you asked. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that thumbwerth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Carrot Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Carrot 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Carrot 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, Much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than negative 360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its two parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just one day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP-76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP-76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP-76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation.
When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Some time before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart. And then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. The appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume. And finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains, covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1,600 of them. Unfortunately, you won't be able to do that because you press the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust. Then you spot bright burning meteors flying towards you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 1,200 miles thick. But that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach the blue marble of your home planet. What will its insides look like, scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 feet thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then, the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 degrees Fahrenheit. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong, it evaporates smaller planets like Mars and Earth. The Sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful: gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water, ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of the ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way, Neptune. It looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why, after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
Deep in the heart of the Large Hadron Collider near Geneva, Switzerland, scientists have embarked on a journey to unlock the secrets of the universe. They've searched for the elusive Higgs boson, a particle that holds the key to understanding the universe itself. And after years of tireless experimentation, the impossible became possible. They finally discovered it. They uncovered a piece of the cosmic puzzle that had eluded us for decades. But what even is the Higgs boson? And why has that changed our understanding of the universe forever? And should you even care? Yes, you should. Just stick with me here. First of all, according to the standard model of physics, the universe is made up of tiny building blocks called particles. You know those, protons, neutrons, and muons. Wait, probably not that last one. Let's scratch it. Anyway, the Higgs boson is the fundamental particle associated with the Higgs field, a field that gives mass to other fundamental particles such as electrons and quarks, which is not the sound that a duck makes, but close. First of all, let's describe the Higgs field. This is one of the fundamental fields of the universe, just like the electromagnetic field, for example, the one that gives us light and electricity. It's like a big, invisible ocean of energy that fills all of the space around us. And just like a real ocean, it has waves and currents. But instead of water, the Higgs field is made up of Higgs bosons. Now imagine you're a tiny little particle swimming through this ocean. Just like a boat in the water, you'll feel resistance as you move through the Higgs field. Some of these particles are like speedboats. They can zip through the Higgs field without feeling much resistance at all. And others, for example the W and Z bosons, are more like giant cruise ships. They're big and heavy, so they feel a lot of resistance as they move through the Higgs field. And that resistance is what gives particles mass. The speedboats that slide easily don't pick up any mass, but giant cruise ships interact with the field more strongly and pick up a lot of mass. Now let's describe that more, scientifically. When a particle interacts with the Higgs field, it creates a disturbance in the field, and this disturbance can be thought of as a Higgs boson. And the disturbance that it creates in the Higgs field is what gives mass to the interacting particle. Basically, without this field and the Higgs boson, tiny blocks of our universe, like protons and neutrons, wouldn't have the mass they need to make up atoms. Atoms wouldn't be able to form molecules, and without molecules, you wouldn't have anything. No matter, no stars, no planets, no life as we know it. Not even bright side. Ooh, makes me shudder. So not only is the Higgs boson incredibly important, but it's also mysterious and fascinating. That's where it got its beautiful holy nickname from. The Higgs boson was first proposed in the 1960s by a physicist Peter Higgs. Good thing his last name wasn't Bozo. Imagine the Bozo boson. Anyway, Dr. Higgs was part of the group of brilliant scientists who were seeking to understand all the different types of particles that make it up. They noticed that some of them, like the photon, which carries light, don't have mass. But others, like the W and Z bosons, do. And they were like, wait a minute, how is this possible? That's when they generated two ideas, the Higgs boson and the Higgs field. But in order to confirm this theory, we needed some proof. And since we can't see the invisible field itself, we needed to find and track at least one Higgs boson. And finding it was an incredibly hard task, like a real-life game of Where's Waldo? All because the Higgs boson is very rare, very short-lived, and doesn't interact with other particles very often. Yep, it's just like me at parties. The Higgs boson is born when a particle passes through the Higgs field and decays almost immediately after that. Now, you may remember how much the science world rejoiced when they were finally able to discover it. That's because it took decades. First of all, this task was taken up by CERN, the European Organization for Nuclear Research. They were using the Large Hadron Collider, or the LHC for short. This is the largest and most powerful particle accelerator in the world, located near Geneva, Switzerland. It smashes protons together at incredibly high speeds, recreating conditions that existed just after the Big Bang. This giant machine tries to find new particles and helps us to understand the universe better. Anyway, the team at CERN used the LHC to generate trillions of proton collisions, searching for the telltale signs of the Higgs boson. But with so many collisions happening at once, it was like searching for a needle in the haystack the size of a small country. The search for the Higgs boson was a long and exciting journey that took decades of work and the collaboration of thousands of scientists from all over the world. And after years of searching, they finally found it: the evidence of the Higgs boson. The discovery was announced on July 4, 2012, and it was major news in the science world. It was celebrated by a lot of parties and events in CERN. But it wasn't over yet. The discovery of the Higgs boson had to be confirmed. So the scientists continued to study it and collect more data. And in 2013, they announced that the Higgs boson had been confirmed with a high level of certainty. This discovery was a really big deal because it confirmed a key part of the Standard Model of physics. The Standard Model of particle physics is the theory that explains how the universe works at its most basic level. It's a way for scientists to keep track of all the different types of particles and how they interact with each other. And the Higgs boson is like the VIP at this particle party. It's a crucial part of the Standard Model. Not only does it help to confirm the Standard Model, but it also highlights the need for new theories and models to explain what the Standard Model can't. Without the Higgs boson, the Standard Model wouldn't make sense, and scientists would have to come up with a whole new theory to explain why particles have mass. But with this holy particle, everything fell into place and the Standard Model was complete. It was like solving a giant puzzle, or finding a glue that holds the universe together. Now, the discovery of the Higgs boson was a huge breakthrough for physics, but it also opened up new questions and possibilities for future research. So, what's next? Well, just like any good puzzle, there are always more pieces to find and more mysteries to uncover. Scientists in LHC continue their research and experiments with the Higgs boson. They're collecting data and analyzing it to better understand the properties of this particle. They're looking at how it interacts with other particles, how it decays, and even how it behaves in different conditions. Also, the Standard Model explains a lot of what we observe in the universe, but it still has some gaps. For example, right now, it can't explain things like dark matter and dark energy. So we've created another area of research: the potential new physics beyond the Standard Model of particle physics. This new area should include things like dark matter and gravity, and some scientists believe that the Higgs boson could become a crucial part of it. It could hold the key to understanding all these mysterious phenomena. To find out if that's really the case, scientists are currently searching for other particles that could be associated with the Higgs field, such as the Higgsinos. They would be a new type of particle that could help explain, for example, how dark matter works. And lastly, researchers are also looking at the Higgs boson's role in the early universe. We want to see how it may have played a part in the formation of galaxies, stars, and even life as we know it. It's like a time machine that helps us understand how the universe came to be. So, all in all, the discovery of the Higgs boson opened a door to a whole new world of possibilities, and scientists are having a blast exploring all the new questions and mysteries that come with it. It's like a treasure map, pointing us to new mysteries to uncover and new theories to explore. Hey, perhaps there is a boson after all.
The sun's heat is beneath our feet. Scientists have figured out that Earth's core is actually as hot as the surface of the sun, around 10,800 degrees Fahrenheit. One of the reasons it's so incredibly hot down there is because Earth is still shedding heat from when it was created billions of years ago. Also, when an object as big as Mars slammed into the young Earth, it not only created the moon, according to one theory, but melted the surface of the planet. A lot of that extra heat is probably still stored inside the core. But there's no need to worry. The planet's core is harder for us to access than it is to probe the surface of Pluto. In fact, chances are we may never develop technology that could physically reach the core. There's no air on the moon. But then, how can it be rusting? Scientists have discovered the presence of hematite on the moon, and it's a kind of rust. A special NASA research instrument examined the light reflected off the moon's surface. It turned out that the composition of the satellite's poles was very different from the rest of it. The moon's surface is dotted with iron-rich rocks, but without oxygen and liquid water, rust can't appear. Solar winds add to the mystery. They bombard the moon with hydrogen, and hydrogen makes it much more difficult for hematite to form. Even though the moon doesn't have an atmosphere, it still has some trace amounts of oxygen. Its source is our planet's upper atmosphere. Earth also protects the moon from almost 100% of solar winds, although not all the time. And even though our natural satellite is bone dry, there might be water ice in the shadowed craters on its far side. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, Mars's gravitational forces will tear Phobos apart, and it will likely result in the formation of a ring around the planet. The Earth is the densest in the solar system. At the Earth's center, there's a core that takes up 15% of the planet's volume. It consists of 2 parts, the outer and the inner core. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles, which makes 20% of the entire Earth's radius and 80% of the Moon's radius. The 1,500-mile thick outer core is liquid. It also consists of iron and nickel, but it's not under enough pressure to be solid. Mars houses the biggest volcano in the solar system. While everything seems to be calm on Mars nowadays, in the past, some sort of force caused enormous volcanoes to form and erupt. One of these volcanoes is Olympus Mons. It's 16 miles tall, which is the height of 3 Mount Everests, and 374 miles across, making it about the size of Arizona. The volcano grew to such a gargantuan size because of the weak gravity on Mars and the lack of tectonic plate movement. Gravity is not the same everywhere. The rocks, metals, and other minerals and substances that make up the planet are packed into the ground more tightly in certain places than in others. This has surprising consequences. Gravity varies slightly depending on where you are. You weigh 0.5% less standing at the equator than you do at the poles. In most cases, that's a difference of less than 1 pound. How high up you are also has an effect. So if you were at the top of Mount Everest, you'd also weigh slightly less. Just don't look down. Earth's toughest living thing is so small you can't see it. Water bears, also known as moss piglets, are cute little creatures with 8 legs and squashed up heads that are less than 1/100th of an inch in length. Despite their microscopic stature, they can basically survive anywhere. They prefer bits of wet moss or the bottom of a lake, but they won't complain if you put them somewhere really uncomfortable. They can endure extreme cold and incredible heat, and survive both huge pressure and high radiation. Some of the little bears once even managed to survive unprotected in outer space for 10 days without a problem. That is tough. They handle all these things by rolling up into a ball and hibernating, which reduces their need for oxygen and food. The moon's gravity is about 17% of that on Earth. If you weighed 200 pounds on our home planet, on the moon, your weight would decrease to a mere 34 pounds. You would also be able to carry stuff 6 times heavier than what you can carry on Earth. It would also be easier to walk on the moon's surface, but it would be more dangerous too. Your feet, inside a heavy spacesuit, would sink into the lunar soil up to 6 inches deep. But let's imagine you decided to skip the tedious process of walking by leaping through the air. Then you'd likely lose control of your jumps in no time. Plus, the moon's surface is littered with deep craters. It would be a tough feat to avoid all of them. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth. So it's perfectly capable of obscuring the star. But in 50 million years, I won't be around then. The moon won't be able to block the sun completely because of the satellite's changing orbit. A full NASA spacesuit costs an unbelievable $12 million. Yeah, I can believe that. 70% of this hefty sum is for the control module and backpack. At the very center of Uranus, there's a rocky core, small, just half the Earth's mass. Compared to other planets, Uranus's core is rather cool, 9,000 degrees Fahrenheit. An ice mantle surrounds the solid core, and that's the largest portion of the planet, about 80%. It's also not the ice you might be thinking about. It's a hot, dense fluid made up of water, ammonia, ice, and methane, sometimes referred to as a water-ammonia ocean. Uranus's atmosphere is mostly hydrogen and helium, but it has its blue-green color because of methane gas that absorbs the red light. The ocean on Jupiter is larger than any other in the solar system, but unlike Earth's oceans, it's made not of water, but of metallic hydrogen. The ocean's depth is a mind-blowing 25,000 miles. That's almost the same as the distance around Earth. Venus is a champ when it comes to volcanoes. The planet has about 1,600 major ones, but none of them is known to erupt. There's a supermassive black hole 250 million light-years away from us. It hums the deepest sound ever detected from any object in the universe. It's 57 octaves lower than the middle C on your piano. That's 1 quadrillion times deeper than what we can hear. Mercury is a few billion years old. In 2016, scientists discovered some abnormalities on the planet's surface, showing that it's getting smaller. After more research, they found out that Mercury hadn't finished cooling down yet. There are planets that aren't bound to any star orbit and aimlessly wander through outer space. Among the most spectacular-looking space objects are pulsars. Pulsars are a type of neutron star. They shoot out some of their material almost at the speed of light. Regular pulsars spin at a reasonable speed, between 1/10 to 60 times per second. But millisecond pulsars can spin at an impressive 700 times a second, which is way too fast for the human eye to even process. As they spin, they emit a beam of radiation from their axis that looks like the light from a lighthouse. Astronomers can notice pulsars when they face Earth, since it looks like a light being shined on our planet. When the light shines elsewhere, the pulsar can't be seen. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Saturn's rings are very thin compared to its size. If you had a scale model of the planet that was 3 feet wide, the rings would be 10,000 times thinner than a razor blade. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot.
While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigeon have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface. and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the Moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claim to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination, and they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system, but this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Earth. Home. The third blue rock from the Sun, the only known planet where life can thrive. We have around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide, give or take. The perfect balance to support our respiration. The troposphere is the lowest and densest part of Earth's atmosphere, 5 to 9 miles thick. It's the part of the atmosphere that keeps changing our weather. For any life to exist, we would need this atmosphere and the same combination of gases to breathe. If all the planets in our solar system were combined to become a mega-Earth, then humans wouldn't have evolved the way we are today, and we'd have a very different planet. If we take the landscape of Mars, we'll only have solid land without large bodies of water. Earth is the only planet in our solar system with bodies of water. One of the first wonders to see will be Olympus Mons, the largest volcano in the solar system. It towers Mount Everest by a long shot at 78,000 feet above the ground. Velis Marineris is a group of canyons that make the Grand Canyon in the U.S. feel like a average one. This wonder stretches for almost 2,500 miles and goes more than 4 miles deep. On top of these epic terrains, there's plenty of other grand-scale locations on Mars that are way bigger than the ones on Earth. The planet might be as large as Jupiter. If the Earth were the size of a grape, then Jupiter would be the size of a basketball. We'd have the size of Jupiter and the rings of Saturn floating around us. The rings may seem like some large chunks of rock in the air, but they're actually ice particles and chunks of iced rocks. They range from the size of pebbles to car-sized ones. Saturn's rings are supported by the unique gravity in the region. With a lot of these ice rocks floating in the sky, there won't be much sunlight entering the planet, which means the planet will always be colder than usual. Not to mention the many moons it has. Our megaplanet could also have many moons circling above us, contributing to the tidal waves. Jupiter is known for the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. The people of Mega-Earth will settle far away from it. Mercury is a planet but looks like the Moon due to all the craters lying around. That's because of many asteroids and comets striking it over billions of years. But the landscape here mainly consists of mountains, highlands, cliffs, and valleys. The Caloris Basin is almost 1,000 miles wide. They believe it was formed by a comet. The deserts on Earth are mainly hot and consist of dunes of sand, but they also have flat plains and small hills. The largest desert in the world is the whole Antarctic continent. Mercury has no atmosphere to trap any heat, so it gets really hot when the sun is facing it and freezing cold when the planet turns away from it. On this combined mega-Earth, The desert will most likely have a similar landscape to that of Mercury. The animals living here will probably be something like giant scorpions and desert snakes that soak in some sun during the day and go out hunting at night. But the soaring day temperatures would melt anyone walking. And even though Mercury is the closest planet to the Sun, it's not the hottest. Venus has temperatures of nearly 900 degrees Fahrenheit. Scientists believe that the lands here are flat because of the extreme temperatures, but it's not all flat, with some volcanoes and highland areas. We can probably find this terrain and climate near the equator, since it's always hot there. Humans can't live there unless they build special domes to sustain life. But since the planet is now huge, not all its territory needs to be populated. Some areas will have the proper atmosphere for breathing, but some places might not have such luxuries. Over at the poles, the climate will most likely mimic Pluto's, even though it's not technically a planet anymore. In 2006, they officially declared it a dwarf planet, and it's even smaller than the Moon. There's not much known about this little mini floating rock, except that it's composed of around 70% rock and 30% ice. Scientists believe that a part of its surface is covered in frozen nitrogen, solid methane, and carbon dioxide. Since the megaplanet is huge, gravity might be quite strong here. Jupiter's gravity is enough to double your weight. Humans will most likely be really tall and mega-sized to match the big planet. Even the oceans will be huge. Our oceans will look like little lakes compared to what Mega-Earth has in store for us. Humans need something close to 24 hours in a single day. Our bodies adjusted to it quite well, but it wouldn't affect us too much if the day had a few extra hours or a few hours less. We can't live on any other planet without wearing the proper gear. We wouldn't last more than a few seconds in places like Jupiter, Neptune, and Saturn. It's possible to last as long as you can hold your breath on Mars. The atmosphere is thin and the gravity is similar to ours, but you might freeze. Even though it's a red planet, it's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and the sunset. Ancient civilizations wouldn't have been as diverse as they were on Earth, since the extreme terrains and conditions wouldn't have allowed for discovery and training. But eventually, as humans developed special technologies for certain areas, different cultures would emerge. Many animals would also evolve in specific and unique ways, but because of the planet's enormous size, isolation, and being on top of the food chain would let certain animals be around since the beginning of the planet without evolving. So it's possible that this mega-Earth might have ancient dinosaurs roaming around, and they'd be even bigger than the ones on Earth. And even though there's a high chance that some humans might be physically different than each other, there might even be more than one species of humans living on opposite ends of the planet. Because of the isolation, they evolved in their own ways according to their surroundings. Over the centuries, technological advancements would spread different cultures around, and we'd be more open to each other. Neanderthals and Homo sapiens once lived side by side and were considered as the two species of humans. Neanderthals were intelligent and used tools for hunting and drawing. Homo sapiens were survivors and wandered around to discover new land. There could be two dominant human species and other minor ones that live in certain areas on Mega-Earth. They'd be bigger, tougher, and faster than us. The ones who live by the trees would have elongated limbs to stretch out and swing from tree to tree. The ones that live in savannas will probably run really fast and have long legs for that. Countries and cities will be bigger than what we have on regular Earth. A country can be as big as Earth itself. The human population can reach tens of billions. Special transportation technology might be invented for people to travel from one continent to another. Covering those distances can take months or even years if using regular aircraft. High-speed trains that travel so fast over land and rocket-like planes going through the sky. Traveling through oceans will require extremely sturdy ships. Traveling through the Atlantic Ocean is already scary for many, so imagine going on a voyage across a body of water that's potentially 8 times the size of Earth. We're going to need a bigger boat. There'll be areas to avoid, like the red spot with its perpetual storms raging on, but the tourist industry might have some room for anyone who wants to see it. Living on such a huge planet is unlikely going to become a reality for most of us anytime soon, but scientists are already discussing moving to other planets to find a new home for humans. I bet you're dreaming of traveling deep into space, but I'm just as sure you don't know even half of all those amazing things that are happening in our home solar system, like ice-spewing volcanoes on Pluto, a potential giant planet lurking on the outskirts of our solar system beyond Neptune, or a giant canyon the size of the United States on Mars. Let's have a look. First of all, let's travel closer to our Sun and see how insanely massive it is. Want some proof? Well, 99.86% of all the mass of the solar system is the mass of the Sun. In particular, hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. I live on one of those. Oh, and even though you might not have noticed it, we live inside the Sun. Wait, I didn't mean we're the inhabitants of the red-hot ball of light approximately 93 million miles away. No. The fact is that the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar winds from the Sun which create such breathtaking phenomenon as the northern and southern lights. Oh, and while speaking of the solar system, you must know that it's a whopping 4.6 billion years old. Scientists came to this conclusion after they studied the oldest material they could get. I mean, meteorites, of course. The solar system is also breathtakingly vast. You'd have to travel 11 billion miles away from Earth before leaving it. Wow, just think of the frequent flyer miles you'd get. Uranus rotates on its side, and astronomers have no idea how the planet chose such an unusual position. The culprits could be ancient mega-powerful collisions, but so far, it's just a theory. By the way, Uranus is the only planet sitting on its side. Its equator is nearly at a right angle to its orbit. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait, it's not the ocean you think about. The one on Jupiter isn't made of water. It contains metallic hydrogen, and its depth is a staggering 25,000 miles. This is actually almost the same as the circumference of Earth. Volcanoes on Earth are different from those on Pluto, like fire and ice. And I mean it literally. While we have scorching hot lava spilling volcanoes on our planet, volcanoes on Pluto spit ice. When frozen, water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano is formed. By the way, as you may remember, Pluto used to be a planet, but this title was taken away in 2006 by some astronomical bureaucrats. Later, Pluto was reclassified as a dwarf planet. But the most unexpected fact about this space body is that its diameter is smaller than that of the US. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,700 miles. As for Pluto, it's only 1,470 miles across. Now, even if you're a tiny celestial body, you can still have a moon of your own. In 1993, the Galileo probe was traveling past a miniature asteroid that was no more than 20 miles across. Imagine astronomers' surprise when it discovered that the little thing had a 1-mile-wide moon. Since then, scientists have found tons of moons orbiting minor planets of our solar system. Jupiter's moon, Io, exists in eternal chaos due to hundreds of smoking volcanoes on its surface. If you decided to visit this place, you'd see the smoke from these volcanoes billowing up high into Io's atmosphere. At any given moment, here on Earth, you can stumble across a rock that once came from Mars. After scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places all over our planet, they came to the shocking conclusion that lots of those have a Martian origin. In many sci-fi movies about space, the main character accidentally gets into an asteroid belt and has to try hard to get away from countless rocks that threaten to damage their spacecraft. Well, it's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is almost zero. Now, beyond the orbit of Neptune, there's a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Unlike what most people believe, there's water all over the solar system, and someone should wipe it up, huh? For starters, it's a pretty common component of comets and asteroids. You can find water in the shallowed craters of the Moon and Mercury. Mars has some ice at its poles, too. The same goes for smaller members of the solar system, like dwarf planet Ceres or Saturn's moon Enceladus. Astronomers even suspect that Jupiter's moon Europa might have some life. Under its frozen and cracked surface, there's likely to be liquid water. Europa is smaller than Earth, but it may host a giant and deep ocean that could contain twice as much water as all the oceans on our planet combined. Now, you might know that Mercury is the smallest planet in our solar system. It's also very dense, the second densest after Earth. But this mini-planet is getting even smaller and denser. After the Messenger spacecraft did its first orbital mission at Mars and mapped the entire planet, astronomers found out that Mercury is very likely to be a tectonically active planet. On its surface, there are cliff-like landforms, also known as fault scarps. They're quite small, which makes scientists think that they appeared not so long ago. In other words, the planet might still be contracting. Now, look at these magnificent rings. You can say without any doubt that this planet is Saturn. People have known about its rings since the 1600s when the first telescopes were invented. But Saturn isn't that unique. Nowadays, we know that every planet in the outer solar system, Neptune, Uranus, Saturn, and Jupiter, has a system of rings. And since we've started talking about the planets of the outer solar system, let's have a look at Neptune. This ice giant is around 30 times as far from the Sun as our home planet, which means it gets less light and heat from our star. But the planet radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers haven't figured out why it happens yet. One of the most unusual moons in the outer solar system is Uranus's moon Miranda. It has craters, sharp ridges, and other bizarre disruptions on its surface. Such phenomena are usually the result of volcanic activity. But Miranda is way too small to generate such a large amount of heat on its own. Astronomers think that it might be the gravitational pull from Uranus that heats and contorts Miranda's surface. But so far, it's just a theory. And there's no truth to the story that Miranda has a brother moon, Lin-Manuel. Finally, our solar system isn't the only one in the Milky Way galaxy. Far from it. The galaxy we live in houses over 100 billion solar systems. And if it's just our galaxy alone, what can we say about the whole universe? Soaring temperatures of more than 11,000 degrees Fahrenheit, solid rocks of blazing superhot fire, immense pressures 3.5 million times stronger than on the surface of the Earth. These are just some of the things cooking 1,800 miles beneath your feet as you're watching this video. How? The Sun is burning with a temperature similar to our planet's core, but it's 93 million miles away. So why isn't Earth melting away from its own core? Our little blue planet is made of many layers stacked one upon another. The inner core, the outer one, the mantle, and the crust. The deeper you go, the hotter and more pressurized it gets. Plate tectonics are layers of the mantle and crust piggyback riding, forever moving and just having a good time. Scientists discovered there are 9 plates in total in different parts of the world. When these plates move and grind on each other, earthquakes occur. Energy is released as a result, and we feel it on the surface. Think of it as trying to shut a car door after stuffing it to the brim. When you realize there's something in the way, remove it and boom, everything topples. Billions of years ago, our lands were all interlocked in what was called Pangaea. But slowly, and I mean slowly, over the years, the continents drifted apart into what we have right now. The Earth was also cooler on the inside, but it slowly started generating more heat in the core. Earthquakes are measured with intensity and magnitude. We see how far the effects of an earthquake reach through magnitude, and the intensity is the measure of its power. Over at the mantle, the cooler rocks begin sinking and hot material from the core rises up. When this happens, the plates begin moving, and as a result, they create mountains, hills, and bodies of water we have today. None of these things happen overnight. It takes millions of years to actually see something. All the way in the layers of the Earth, there are different sources of heat, mainly from when the planet was initially formed. Friction heating occurs when materials begin sinking down to the center of the Earth. Since the Earth is surrounded by a solid mantle, the crust floating on top of it acts as a barrier to protect us from the Earth's insides. But the secret for its success is the difference between heat and temperature. Simply put, heat is just energy, and temperature is its density. If the Sun was 1,800 miles away from the surface of the Earth and boiling at the same temperature as our core, we would melt like ice cream on a hot sunny day. A shock from a small short circuit when plugging out your phone charger from the socket won't be too harmful, even though a spark can have temperatures of around 2,700 degrees. But if you dipped your body in a boiling bath of hot water at around 200 degrees, let's just say it's not worth it. Just because the temperature of the Sun's surface is roughly the same as the Earth's core, doesn't mean the heat distribution is the same. The Earth's core is teeming with iron throughout the layers, but on the surface, the iron atoms are arranged into cube shapes. That's when iron is in normal room temperature and regular pressure. But put in extreme conditions, the atomic shape changes into hexagons. For a long time, scientists thought that the iron in the core was hexagon-shaped, but they found out it retained its cubic formation 1,800 miles underground. Since the core has so much pressure, the atoms simply don't have a place to move to change their shape. If you were standing in a subway train that was packed full, you wouldn't even have space to lift your arm. But everyone inside is able to switch positions while keeping the original shape. That's why the structure of the Earth's core is solid and not liquid. The atoms are so tightly packed that they can't even transition into a liquid state. But in a world where the Earth's core liquefied, we'd witness the worst consequences, starting with major and mass volcanic eruptions, earthquakes, and tidal waves. Every major hotspot would be in danger, and the Ring of Fire would be a non-stop fountain of lava spewing out. Cool material from the upper layers sinks down to the core and vice versa. With a liquid and incredibly unstable core, this process would be much faster. Every major city and town by the coast would be washed away by tidal waves, and all the volcanoes erupting will blacken the sky with ash and smoke. This would temporarily block the sunlight from entering our atmosphere and eventually force anything flying in the air to remain on the ground. The lands we currently live on would feel like ice breaking away from a glacier and floating off. Many dormant volcanoes would wake up from their slumber and spew out their morning lava all over the place. The ground formation and structure would change permanently. Magma from the bottom of the ocean trenches would find its way up to the surface and change the currents in the oceans. The Arctic Ocean and Antarctica would melt away and add to the rise of water levels all around the northern and southern hemispheres, and eventually the world. Wildlife on land wouldn't be able to flourish, and all the greenery would disappear. Marine life would have to find a way to escape the changes in the ocean temperature. The world economy would crash as an international emergency would be declared to try and figure out a way to stop this. But humanity would barely make it alive and would have to strive to continue existing. Well, of course, something like this will never happen. But if the Earth's core cooled down, then we wouldn't have massive volcanic eruptions, no devastating earthquakes nor tidal waves. In fact, none of these things would happen since they require energy to function. The continents would stop moving and changing. Sounds cool, right? No. This means that the magnetic field protecting our planet would disappear. which would make us extremely vulnerable to cosmic radiation, as well as asteroids and meteorites. The sun's rays will feel even more intense than usual, which will make it extremely unsafe for anyone to go outside. The heat produced in the core is responsible for recycling the carbon that goes back to the surface. Now, recycling would stop altogether. Carbon is an essential part of carbon dioxide that plants need to survive. So all the trees and plants on the surface and in the water would stop growing and wouldn't be able to produce oxygen for the rest of the world. With cosmic radiation and lack of oxygen, humans would have to live in bunkers with artificial ventilation systems. The Earth's surface would become a no-go zone and start to resemble Mars. With nothing to power the Earth from the inside, it'd begin to dry up and crumble internally. Much of the Earth's surface is made out of oxygen, so without it, we would eventually see something like major sinkholes around the world. Sinkholes that can take down cities like New York and Paris, along with landslides in many cities and unstable landscapes all over the place. Every single city's infrastructure would eventually collapse and make the ground unwalkable. So even if you did live in an underground bunker, chances are the foundation wouldn't last and you'd be exposed to the cosmic radiation. But all of this can vanish in the blink of an eye if an asteroid comes falling down. Whether it's tiny or colossal, we would be seeing more of those than actual rain. Without a magnetic field, the Earth can't block any foreign object that flies through our atmosphere. If an asteroid the size of Rhode Island came falling down, the damage would be much more than with the Earth's core hot and running. With the ground as fragile as potato chips, the ripple effect would be much wider and cause more indirect destruction around us. The Earth would eventually collapse in on itself and break into pieces until it's lost its own gravitational energy. It'd end up being a bunch of rocks and pebbles floating around in the emptiness of space. But nothing like that will happen either. We're living fine with our solid hot Earth core. As long as it's doing okay, then we can keep on doing our thing. The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer, though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And, most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P/Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the Sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's Comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Sheqi and Wenxian Thungkao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar, around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the Sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets, in general, may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small rocky space bodies also orbiting the Sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the Sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs.
Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics, and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own Sun. This giant of a star burns bright and hot, shining with the light of a million suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom. A blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now, imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack. Only instead of a needle, it's an invisible and mysterious object. And instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time, caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of 2 black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. It's like trying to spot a criminal by their fingerprints. For example, if a black hole is located near a star, scientists can observe the star's light being distorted as it's pulled toward the black hole. And of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. All these things will bring us closer to uncovering the secrets of quasi-stars. And when we find out the truth about them, it will become a new page in our scientific history.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown. 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer, and the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes, so it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid. And it would make for one epic light show. You're on a spaceship flying through outer space at a speed of 180,000 miles per second. This is almost the speed of light. Make yourself comfortable, because the voyage is going to be long. It will last a little more than 90 years. It's better to use a cryo capsule to not get bored. In short, you need to fly for almost a century at the speed of light to get to a mysterious exoplanet that scientists have recently discovered. They have found many planets in the last few years, but this one can help in the search for extraterrestrial life. The planet looks like a dark blue ball and has a complex technical name consisting of letters and numbers. It's about the size of Neptune and orbiting around a little star of class M, or in simple words, around a red dwarf. The planet is 8 times closer to its star than Earth is to the Sun. But this doesn't mean that fiery layers of magma cover the surface of this world. The temperature on this exoplanet is pretty low and similar to Earth's. That's because the red dwarf is not as hot as our Sun. But the most exciting thing is that the atmosphere of this space object consists of water vapor, or helium hydrogen. Scientists don't know for sure, so they actively observe it. But if there is water in its atmosphere, then life can exist. It's unlikely we will discover some big creatures, but even microscopic bacteria would be a big sensation. Another reason why scientists keep their eyes on this planet is its origin. If they find out what the planet's atmosphere is made of, they'll understand how such objects can form around red dwarfs. This will be another little brick of understanding of how the universe works. Even if they discover life on this strange planet, it will be impossible to transport it from there for us to study. Fortunately, there's another massive object near Earth where microbes can live, and it's located inside our solar system. In 2020, scientists detected a strange gaseous substance in Venus's atmosphere. These were chemical residues of phosphine. This is a significant finding because phosphine exists on Earth near some microbes. They've recently discovered phosphine in penguins' bodies. Many people started to put out theories that these animals came to us from Venus. But, of course, this is not true. You can also find this substance among swamps and mud. so it was a big surprise when they found residual phosphine parts on another planet. It's weird, since life on Venus's surface most likely cannot exist. The temperature and pressure on the planet are just too high. But high up in the sky of Venus, the conditions are not so terrible. Perhaps some microbes live there. But scientists also know that volcanoes often erupt there. A chemical trace of phosphine may appear as a result of these eruptions. If this is the real reason for the appearance of phosphine, they probably won't find any life. Now they're spending a lot of money on the study of this planet. But let's go back to deep space. Over the past 20 years, scientists have been finding exoplanets far and not too far from us. Some of them orbit around dwarfs and big stars, but some planets exist entirely alone. They don't belong to the orbit of any star. They are abandoned in cold outer space. Another exciting thing is that scientists haven't found a planetary system similar to our solar one. All distant exoplanets are located at different distances from their stars. Their sizes and masses are not like those that our planets have. We call them exoplanets since they're beyond our solar system. Some other fascinating space objects are super-Earths. If some planet weighs from 2 to 10 Earth masses, is 2 times bigger, and gets energy from a star, it's called a super-Earth. No more similarities with our home. Super-Earth can consist of gas, rocks, water, ice, fire, acid, glass, or diamonds. Scientists haven't yet found a super-Earth with ideal conditions for humans. Not because all planets are bad for life, but because our body has evolved and adapted to Earth only. We don't know much about super-Earths. They contain a massive amount of energy because of their enormous masses, and this energy is released. Therefore, frequent volcanic eruptions and earthquakes occur on many of these planets. Thunderstorms happen there almost every day. And by the way, one day there lasts several times longer than our 24-hour one. Let's imagine you're on the spaceship again, traveling to some super-Earth. So here it is, massive, orange, majestic. You put on a spacesuit, get into a space capsule, and you change your mind. The whole planet resembles a fiery, boiling ball. If it has any life, it must be some invulnerable creatures. You're not like that, so you fly away to look for another super-Earth. A couple light years away, that giant ball seems to be a friendly place. Wait, this world is located far from its star. The temperature there is so low that even molecules freeze. Antarctica is like a hot desert compared with this super-Earth. You continue your voyage and finally find a perfect spot. It's 3 times heavier and twice bigger in size than Earth. It consists of rocks, gases, and possibly water. You descend to the planet on the transport capsule, open the door, and take one step. Your legs are too heavy. Your whole body has gained weight. You feel as if you were carrying a huge box of bricks on your back. You can't even walk a few feet. And the reason for this is gravity. The greater the weight the super-Earth is, the greater its gravitational force becomes. You're pressed to the ground, and your muscles are too weak for this. Also, increased gravity provokes active fluctuations of tectonic plates. Earthquakes and landslides happen on this planet pretty often. The rocky surface here is constantly changing. To live on such a planet, you would need to develop new technology to build houses. You get back into the capsule and fly away, but not too far. The planet's gravity doesn't allow your ship to rise high into the sky. It's like ropes pulling you down. You use all the remaining fuel to overcome the gravity and go beyond the atmosphere. Another problem with such worlds is meteorites. Gravity attracts not only your ship, but also colossal space objects flying by. A giant asteroid can get off its route because of the attraction of the super-Earth. It can hit the planet in the form of a meteor shower, but the falling speed is also faster, so the destruction will be more massive. But the worst thing that can happen to the super-Earth is the stoppage of the planet's core, caused by high pressure. Hundreds of billions of tons of solid rock can squeeze the heart of this world, and the core should always be in motion to perform its primary function, keeping the magnetic field working. Solar storms and cosmic radiation can create severe problems for all life on the surface. On Earth, these storms disrupt the operation of electronics and affect human health. This happens even if small holes appear in the magnetic field. And what would happen if all the protection disappears? The energy of the closer star and the radiation from distant space would quickly destroy the super-Earth and make it impossible for life to develop. All these events can happen to a super-Earth with ideal conditions for living. And such a planet is a rarity. Most super-Earths have terrible surfaces and atmospheres. There's a planet where the air is so hot that it can evaporate metals. The fiery wind simply splits any solid substance into molecules. Such a super-Earth is more like a star, not an ordinary planet. Also, there's another super-Earth, wholly covered with water. You won't find a single piece of land there. The ocean floods any island in a second. And underwater, there are volcanoes. They erupt almost every hour, releasing billions of tons of magma. Because of the heavy weight, the planet is slightly tilted. When it rotates around its axis, the water flows from one side to another. This creates huge destructive tsunamis bigger than the size of Everest. And how about a super-Earth where it's raining diamonds or sulfuric acid? The surface of another distant world is blown by winds consisting of glass. There's a lot of fire and sand. When the hot air burns the sand particles, they turn into glass. Among all such planets, ours seems to be a paradise. But perhaps for some strange organisms living at the distant end of the galaxy, Earth may seem to be a terrible world.
What would happen if our planet turned into two separate ones, one consisting entirely of land and the other one of water? Could we survive on any of them, and how? Well, you're lucky, because I'm going to answer this question right now. So let's imagine that our Earth has turned into two separate planets sharing one orbit. Let's call these hypothetical planets rock and water. I know, very original. Anyway, let's start with the rock because this one is much easier to imagine. All we should do is ask, what would happen if all the oceans on the Earth suddenly dried up? Now, we know that water is life. It covers 70% of the surface of our planet. There's so much water that even if all the oceans and seas disappeared, some of it would still be left in underground rivers, streams, and so on. But unfortunately, it would not be enough for us to survive. All sea creatures disappear. After some time, all other animals, plants, and of course, people share their fate. Completely dried forests burst into flames sooner or later and burn until there is nothing left but ashes. But hey, it's not that bad. Well, it is bad, but life can still exist in some form. There are some bacteria that make cockroaches jealous. They're able to survive absolutely any conditions. For example, extremophiles have already evolved to live without water. These little guys can survive in an incredibly hot or acidic environment without water or even sunlight. Without them, the rock becomes an empty, lifeless planet. Although, who knows? Maybe someday extremophiles will be able to evolve into some wildly cool forms that can survive literally anywhere. But for now, the rock is just a floating rock, basically. Oh wait, did you imagine a hot desert or some sort of red-hot steppes? Surprise, surprise! This planet is actually extremely cold. You see, without water, there would be no atmosphere. The atmosphere consists of a concentration of various gases, including hydrogen and oxygen. Some H and O. You know where this is going, right? Yep, no water, no atmosphere. And since it is the atmosphere that accumulates all the heat we need, the planet would be very cold without it. The contrast between cold and less cold places also becomes very sharp. You see, water is basically a climate stabilizer. The oceans absorb almost all of the heat of our sun. They distribute it evenly over the Earth to make sure it doesn't get too cold or too hot. So without it, the rock gradually turns into a cold desert. The average temperature on this planet is around minus 100 degrees Fahrenheit. At both poles, the temperature is extremely low, about minus 300 degrees. And even in the warmest places, it doesn't exceed 20 degrees. These warm places are now the former oceans, because their dried-up depths are located much closer to the hot core of the planet. Wait, I hope you don't imagine this planet as covered in snow either. We don't have any water at all, remember? It's just a very cold rock. At this point, we're just a bigger and browner version of the moon. The moon is basically a waterless piece of Earth, after all. But hey, what happens to volcanoes? They're basically our last hope to stay warm, aren't they? Unfortunately, volcanic activity is decreasing due to a lack of water. You see, volcanoes and their eruptions happen because of the collisions of two tectonic plates, the oceanic and continental ones. The weight of the water presses on the oceanic plates. They go under the continental plates and form volcanoes. So if there's no water weight, then there's no volcanoes and volcanic activity drops significantly. The rock now is just a planet full of many incredible high mountains. And every time the tectonic plates collide, they form more and more of these mountains and trenches, including some very big ones, like the famous Mariana Trench. I would say, be careful not to fall, but hey, there's no one to fall there. Also, there's no weather anymore. No water means no more snow, ice, or rain, or even clouds. The wind would probably be quite strong, though. Well, that's the fate of the planet rock. Not very bright, so let's just go see how the water planet is doing. Many, many billions of years ago, I wasn't around then, our Earth actually was a planet entirely covered with water. Then, about 1 billion years ago, the sea level dropped, the land appeared. This has changed the atmosphere of our planet forever, and that's how life was born here. But what happens if it returns to its original state? Well, to answer that question, we should first learn more about the ocean planets. So, what does one of these look like? Oh, sorry, I almost forgot. We have no idea. We haven't found any planets of this type because they're incredibly rare. I mean, there is one planet that is low-key and could be called an ocean planet. Yeah, I'm not even going to try and pronounce that. Still, even this one doesn't look the way you probably imagine. The water on it is in a very weird, unique state. Scientists have called this hot ice or superliquid water, and we've never seen anything like this before. In general, though, the actual ocean planets are very hard to find due to many physical reasons. These planets require very specific temperatures, pressures, and so on. But alright, just hypothetically, what would such a planet look like? Well, first of all, of course, it cannot be made entirely of water. I hope you didn't actually think that there could be just some gigantic water blob spinning around a star. It should still be a planet with a core and some kind of foundation. So let's just imagine that all the water on the former Earth has mixed into one giant salty ocean. Wow, that would be a dream come true for the sea creatures, but not for the rest of us. The only animals that could survive in this situation, except fish, are probably the birds that can swim and feed on fish. Now, I think even if the sea level rose significantly, at least a couple of islets could still stay above the water. Such islands would be the former peaks of huge mountains like Mount Everest. So if these birds build their nests there, they can even survive for some time. But what about you and me? Well, we still have a chance. If we had enough time to prepare for the huge flood, we could stay safe either in giant submarines or on giant ships. We can grow food on board and fish from the ocean. But without the Everest Islands, we are unlikely to last long. If something breaks and we have nowhere to dock, we won't be able to fix it. Unfortunately, we no longer have drinking water. Now we can get it only from rain or by filtering seawater. But we have to store it someplace, right? And all these water containers would take up a lot of space and be very heavy. But in general, planet water is not as bad as it might seem. It's quite warm. The average temperature here is about 50 degrees Fahrenheit. And the gap between the lowest and highest temperatures is minimal, from minus 20 degrees at the poles to 70 degrees at the equator. Compared to planet rock, this ain't bad at all. Planet water would also be slightly larger than the Earth in radius due to the volume of, yes, water. The density of this planet would be, on the contrary, quite low. The gravity could become a bit weaker, too. Now, as for both planets, if we place them in the Earth's orbit, after some time, they would still move away from each other and follow different trajectories. They would have aligned themselves not to collide with each other. On one of them, the year would last 12 months, and on the other one, 10 or 11. And that's about it. A fun fact, all of this can actually happen in the future. First of all, the Earth's crust is gradually becoming thinner. Hey, I like thin crust. On my pizza. On my planet, not so much. So, one day, water can really flood our entire land. On the other hand, in a couple of billion years, when our sun begins to expand and turn into a red giant, all the oceans on our planet will really dry up. Alright, take a deep breath and shake it out. That's enough of this grim fairy tale. It's a waste of time to worry about such things so far off when, today, I can't find my wallet anywhere. I thought I put it over here.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernardinelli Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernardinelli Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernardinelli Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it'd produce a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernardinelli Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernardinelli Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the Sun. That's 20 times the distance from Earth to the Sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernardinelli Bernstein will approach the Sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the Sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the Sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the Sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bang! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the Sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the Sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the Sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. Koi 571501 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. Koi 3010.01. This planet is found next to the star Koi 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.
A long time ago, we believed that the entire universe revolved around our own little blue planet. It's called a geocentric model. We thought that the sun, the stars, and all those twinkling celestial bodies all danced around us. This theory was super popular in ancient Greece and Rome. Famous geniuses like Aristotle and Ptolemy really loved this idea. Why did people believe this in the first place? Well, first of all, we have a massive ego. Second of all, there were a couple of things that seemed to support it. For example, if you stand on Earth and look up at the sun, it seems like the sun is spinning around us once every day. The moon and the planets seem to be doing the same thing. The obvious conclusion is, oh, they're probably twirling around the Earth. Then there's the fact that Earth feels pretty steady when you're standing on it. It just doesn't feel like it's moving, you know? And because of this stability beneath our feet, people thought that the Earth was unmoving. But even back then, there were ancient Greek and Roman philosophers that were onto something cooler. They paired the geocentric model with the idea that Earth was actually a round ball floating in space, not a flat disk. They started connecting the dots. And after a while, astronomer and mathematician Aristarchus of Samos had a game-changing idea. He thought that the Earth might not be the center of everything. He proposed that everything revolved around the sun. Funny to think that back in the days, this idea was considered insane. That's why for a while, most people stuck to their geocentric views. It took us many centuries to finally accept the heliocentric model, where all the planets in our solar system revolve around the sun. This idea was brought to life by people like Copernicus, Galileo, and Kepler. This change wasn't easy for people. It was hard to let go of our space crown. But gradually, we came to terms with it. And by letting go of this idea, we discovered a whole new world. This journey led us to an astonishing realization. Not only we're not the center of the universe, we're nothing but a little speck in it. We're a microscopic dot, sprawling galaxy called the Milky Way. The discovery of the Milky Way started right from our own backyards. If you've ever gazed up at the stars on a clear night, you might have noticed a faint, luminescent band stretching. It's like a shimmering celestial ribbon woven with stars. That is our galaxy. It was named Milky Way because it looks like someone spilled milk on a road. It was perfectly depicted in the 90s by Voyager 1. NASA's spacecraft took a picture called the pale blue dot. That tiny little pixel that's almost impossible to see is our planet. The photo was taken from a chilling 3.7 billion miles away from the sun. On a universe scale, this distance is nothing. But for us, it's unimaginable. So when scientists discovered the Milky Way, they armed themselves with telescopes. Their goal was to map the uncharted territories of the night sky. And of course, to find our place in this gigantic world. To do that, first, we had to unlock the secrets of our galaxy's structure. Okay, so we can clearly see that it has some band-like formation. That probably means that our galaxy is not a big, round ball, like the planets and stars. In reality, it's more like a giant pancake, a flattened disk. And we can see that we're not above it, and not below it. We're right on the plate. The next step is to travel across the Milky Way to map it. There's a little problem, though. To do that, we'd have to traverse thousands of light years perpendicular to this pancake-like plane. Just to put things in perspective, think of Voyager 1, the one that took the pale blue dot picture. That spacecraft has been journeying through space for almost half a century. It left the solar system years ago. You know how many light years it traveled? 0.002. And how many light years is the Milky Way? 100,000. You get the picture. But the lack of fancy technology didn't stop us. In the 18th century, a bold astronomer named William Herschel decided to explore our galaxy. With nothing but a telescope, this Indiana Jones of astronomy started mapping the stars in the night sky. As a result, he discovered Uranus, more than 2,000 nebulas, and created the first map of the Milky Way that depicted it as a disk. The map wasn't super accurate, but still very impressive. Unfortunately, he didn't know about something called interstellar dust. It's like space fog that can block our view of stars in the center of the Milky Way. This dust made the central region of the Milky Way appear less crowded than it actually is. Now, let's go all the way to the 20th century. Henrietta Swan Leavitt, an American astronomer, was another curious stargazer. But she focused her attention on a special kind of star called Cepheid variables. These stars had a unique quirk. They pulsed, getting brighter and dimmer in a predictable pattern. Leavitt's job at the observatory was like being a librarian. She cataloged these special stars, and in doing so, she stumbled upon something incredible. A direct link between the brightness of these stars and the rate of their pulsations. This discovery is now known as Leavitt's law. It meant that by simply measuring how quickly these stars pulsed, astronomers could figure out how far away they were. These pulsating stars became the rulers for measuring distances. Before the 1920s, most scientists believed that our Milky Way was the only galaxy in the universe. But as telescopes improved, some astronomers started realizing that this isn't the case. We started finding more and more galaxies. But if the Milky Way was just one of many galaxies, where exactly were we within it? Meet the scientist named Harlow Shapley. Armed with a powerful telescope, Shapley turned his attention to globular clusters. These are tightly packed groups of ancient stars that gather together in spherical shapes. That's when he noticed something interesting. The oldest stars around us weren't scattered all over the canvas. They were clustered around the center of the Milky Way, and they were pointing in the direction of certain constellations like Sagittarius and Scorpius. It turns out that the origin of our galaxy began from the center. It was the heart of the Milky Way, and the most ancient guys were hanging out there, which means we're not even at the center of our own galaxy. Seems like our importance becomes less and less with each new discovery, huh? Anyway, Shapley found out that we were positioned somewhere on the outskirts of our galaxy. Shapley's calculations weren't perfectly accurate, but he got pretty close. Luckily, now we have very precise and cool tools. Since then, we've since pinpointed our precise location. We're located near a partial arm of the Milky Way called the Orion Arm. It's about 26,000 light-years from the heart of our galaxy. And that was the story of how we found out where we are in the Milky Way. You think our story is over? Oh, absolutely not. Meet Gaia, the European Space Agency's celestial cartographer. Launched in 2013, Gaia embarked on a daring mission. It has to map the Milky Way in unprecedented detail. Not just some rough map, but a photographer capturing every nuance of our galaxy. Gaia is piecing together the positions and motions of about 1 billion stars, and it's like 1% of the stars in the Milky Way. But even that tiny fraction is enough to create a masterpiece of cosmic cartography. What a grand journey it was. It led us from thinking Earth was the center of the universe to realizing we're less than a speck in the grand scheme of things. But what's more important is that this story shows humanity's drive to uncover the mysteries of the world. And there's always something new to explore. Discoveries just keep coming, so stay tuned and keep looking at the night sky.
Today, we're going to work our core, so get ready to sweat. Oops, sorry, wrong core. Hey, we've traveled far and wide, down to the Earth's inner core and up into outer space. But what if we could combine these adventures and find out what hides in the innards of other planets and moons in the solar system? With the help of this interstellar hyperdrill, we can achieve that, at least in part. Coordinates are in, all systems ready, and our first destination is the Moon. Our moon, in fact. We land on its gray and desolate surface under the black sky. No blue here because there's very little atmosphere to disperse the light. The drill starts working, and we first go through the outer layer of the moon, the crust, just like on Earth. We're on the sunny side, so the thickness of this layer is only 43 miles. But were we to land on the dark side, it would be more than twice as thick. The moon is a rocky body, so its crust is largely made of silicon, iron, aluminum, calcium, oxygen, and magnesium, with much smaller amounts of other elements. Further down, we find the mantle, and it's a long and tedious journey through. This layer is about 850 miles thick. It gets hotter as we go deeper, finding composite minerals, pyroxene and olivine. They're made of iron, silicon, oxygen, and magnesium in different proportions. Finally, we break through the hard layers and into the semi-molten outer core. Another journey of about 93 miles ahead through this scalding swamp. And we dive into the iron ocean of the liquid core shell. It's nearly 60 miles thick, and the molten metal threatens to evaporate us. But this drill was made to sustain an extremely heavy onslaught. And that's how we finally come to a sudden halt. In the deepest reaches of the moon, there's a solid iron core, which is 150 miles thick. We could drill through it, but it would be unnecessary. So we just set the flag here and skip to the next planet on our drilling list. And it's Mercury. It was hot deep inside the moon, but on the surface of the smallest planet in the system, it's even hotter. That's because it's so close to the sun, of course. Alright, let's drill. Mercury has a pretty thick outer shell, which is both crust and mantle, going about 250 miles deep. Not the most fascinating journey, it's not unlike the Earth in many respects. But then, the drill stops, ramming into a solid metal wall. It's Mercury's core, which has a diameter of over 2,500 miles. It takes up to 85% of the planet's overall diameter. No use trying to drill through this one. It's fully metal and extremely dense. Skipping to the next planet, and we're on Mars now. Oh look, it's sunset here, and the sun is making the sky hazy blue. But you know the drill. I mean, we're here to drill, so that's what we do. Mars's crust is quite thin compared to Earth's, just 6 to 30 miles deep. Its composition is much the same though: iron, aluminum, calcium, potassium, and magnesium. That's one of the reasons why humans are looking to colonize the red planet one day. It's very similar to our own. We're very quick to drill through the first layer, and the second one, the mantle, is now upon us. It's a hard and rocky layer about 1,100 miles thick. Thanks to its size, Mars isn't seismically active any longer. There's simply no magma boiling close underneath the surface of the planet, making it silent and docile. It's a long dig, but we finally come to a screeching halt, bumping into the core. A ball of iron, nickel, and sulfur with a diameter of 2,000 to 2,600 miles. This core is bigger than that of Mercury, but the planet itself is larger too, so it figures. Okay then, our next stop is even more interesting, because it's Jupiter. This gas giant has a mass twice that of all the other planets in the solar system combined. And we landed right in the middle of an ocean. The ocean, I dare say, it's the largest one in the whole system, and it's made of liquid hydrogen. The drill goes smoothly through the surface of the planet because there's no rock or hard metal here, only gas and liquid. But the shaking, yikes! The pressure on this planet is more than just huge, it's unimaginable. The drill is barely able to withstand it, and as it's going deeper, the pressure's becoming higher too. We've reached Jupiter's core, and it's nearly too much to bear. The temperature here is about 90,000 degrees Fahrenheit, and the core itself is not solid but liquid as well, kept together by the immense pressure from all sides. The drill starts to rattle. Bad sign. Let's get out of here before it breaks. Whew! No winds, no pressure, no heat. All around us is a vast icy wasteland, crisscrossed by ridges and reddish bands. It's Europa, one of Jupiter's most promising moons. As we drill through the ice, let me explain. Europa is one of the candidates to have extraterrestrial life in the solar system, and it can be found right beneath the icy shell through which we're now digging. It's only 10 to 15 miles thick, while down below is an enormous saltwater ocean, twice bigger than all of Earth's oceans combined. The deepest point on Earth is Challenger Deep, and it's a bit over 6 miles down. The ocean on Europa, on the other hand, can be up to 100 miles deep. Who knows what can be lurking in that deep, dark sea? Anyway, we travel fast through the water and finally reach the bottom of the ocean. The mantle starts here, and it's made of rock, just like on Earth. And not much deeper in, we find the metal core of the moon. Europa is a little smaller than Earth's moon, so it's no surprise we reach its center pretty fast. Okay, skip drive on. Let's go further. Oh, I'd rather we drill in as fast as we can. Just look around, it's blazing here. We're definitely on Io, another moon of Jupiter, and the most volcanically active world in the solar system. Look, that volcano is twice the size of Everest, and it's erupting right now. Thankfully, we're under Io's surface already, but that's not to say we're safe. It's all molten down here too, mostly yellow and brownish hue, due to the huge amounts of sulfur. The stench must be horrible. Anyway, the most peculiar feature is that both inside and outside, everything's always on the move on Io. Jupiter and its other moons create tremendous tidal forces, making the surface of Io swell over 300 feet up and down. Like the largest tsunamis on Earth, only here it's not water but rock. The deeper we go, the calmer it gets though, until we're finally at the iron core. It's still hot here, but at least there's no shaking and swelling like above. Let's put up another flag and go to the next point. And that would be Saturn, the second largest planet of the solar system and the one best known for its spectacular rings. Not the only one to have them at all, mind you, but we'll get to it. Now, as you've surely noticed, our drill is simply falling down through the gaseous hydrogen and helium, making up most of the planet's surface and atmosphere. No need to work here, just wait and hope the immense pressure won't crush our drill to a hunk of junk. At last, the pressures become so enormous that we find ourselves in the liquid hydrogen, and here we start diving. Soon we'll reach the solid core of Saturn. Here we are. It's made of iron and nickel and is actually quite small compared to the rest of the planet. Well, the last destination awaits, so come on. And here we come, Neptune. The drill immediately deploys anchors because the winds here are extremely powerful. They reach speeds 5 times greater than the most devastating hurricanes on Earth. Neptune is covered in a pretty thin layer of hydrogen and helium, just like Saturn or Jupiter. But underneath, there's much more than that. It's hot, windy, and lonely here on the outskirts of the solar system. So let's dig already. Beneath the gases, there's suddenly a bubbling hot mass of water, methane, and ammonia. Phew! These substances are hot, despite Neptune being called an ice giant. The name comes from its core. Deep inside, where we're quickly headed right now, a small ball of rock and ice sits all alone. And despite the boiling temperatures above, the ice beneath is ever cold.